Everyone can hear me? Online students? Online students, can you please confirm if my voice is loud and clear? Okay, done. So let's start the session. So in the last class, we have discussed about the regularization, right? And once again, let us have a small recap of whatever we have discussed in the last class. That is regularization. The main purpose of regularization is to reduce the overfitting problem. The main purpose of regularization is to reduce the overfitting problem, right? This is the main of regularization. And now within this regularization, we are having first one is called as ridge regression. Ridge regression means where in the ridge regression, we are going to do sum of squares of errors, that is y minus y hat whole square. This is sum of the squares of errors plus alpha into sigma of beta whole square, where this beta is slopes, sigma of the slope whole square. We are going to consider the sigma of slope whole square. That is nothing but, for example, if you take a TV, radio, newspaper example, beta 1, beta 2, beta 3. So I require the same beta 1, beta 2, beta 3 and beta naught in such a way that y minus y hat, that is beta 1x minus beta 2x beta 2x2 minus beta 3x3 minus beta naught whole square plus alpha into beta 1 square plus beta 2 square plus beta 3 square. I want the equation. I want to identify the beta values such a way that this should be minimum. In such a way, it should be minimum. My requirement of calculation earlier in the linear regression, if I go with the linear regression, in the linear regression, what I have to do, just let us once again discuss the linear regression. In the linear regression, sigma of y minus y hat whole square should be minimum. In linear regression, if you are having the same three, that is TV, radio, newspaper, and says x1, x2, x3. So the same three input variables you are having. Now for same three input variables, x1, x2, x3, you are having beta 1, beta 2, beta 3. You are in linear regression. In linear regression, we calculate, we estimate, instead of calculate, we estimate the beta 1, beta 2, beta 3, and beta naught. Three coefficients along with the intercept. We are going to estimate the four values in such a way that we get the sum of the squares of errors as minimum. This one we get as minimum. We'll identify these four values which can give this value as the minimum value, which is nothing but sigma of y minus beta 1 x1 minus beta 2 x2 minus beta 3 x3 minus beta naught whole square. This value for us we required as the minimum. So we are going to apply the linear regression. Linear regression concept is identify the beta 1, beta 2, beta 3, and beta naught. Identify these four values in such a way this entire one should be minimum. Substitute whatever the values you want. Substitute whatever the beta 1, beta 2, beta 3, and beta naught values you want, you substitute. But finally, the ultimate goal should be this one should be minimum. Similarly, here also substitute the same beta 1, beta 2, beta 3, and beta naught, same to same. But this time, instead of only this one minimum, this one also overall it should be minimum. Including this one, it should be minimum. That is the difference between both of them. Got the point? In this case also, we are calculating beta naught, beta 1, beta 2, beta 3 only. If you observe the multiple linear regression, first we have fitted on X train, Y train. After fitting on X train, Y train, let us see the coding part once. Just to have a coding part once. In the multiple linear regression, just I'm opening only the linear regression. In the multiple linear regression, in the coding part, so modeling, exclusively in the modeling. In the modeling, I'm fitting on X train, Y train, and from this, I'm calculating the beta naught value, beta 1 value, beta 2 value, and beta 3 value. These 4 values I have calculated. These 4 values, how this has formed, how you got these 4 values means these 4 values will give the sum of the squares of errors as minimum. These 4 values make a formation in such a way that the sum of the squares of errors is minimum. Now, in this case, how it has calculated this one in the max, what is the max means? It is applying the d by dx. And from that, it is calculating the separately beta 1, separately beta 2, separately beta 3. And from that beta naught, it is calculating. Now, the same logic will be applied in the lasso ridge regression also, same to same. If you apply the ridge regression or if you apply the lasso regression, there is no change in the data pre-processing. Up to data pre-processing common. Now, once you do the ridge regression here, the from sklearn.linear model, if you import the ridge, and here whatever the alpha value you are going to substitute, if you don't take anything, by default, it will take the alpha is equal to 0.1 by default. And if you fit on the X train, Y train, now after fitting on X train, Y train, now if you ask the intercept value, I'm printing the ridge dot intercept. If you ask the intercept value, whatever we have asked here in this multiple linear regression, how we calculated the intercept and coefficient values, in the similar way, I'm calculating the same to same for the ridge also. Okay, for ridge also, I'm calculating in the same way, the coefficient values and everything. Okay, if I calculate for the same to same, the coefficient values and the intercept value, how many values I'm going to get now? Same to same. Same 4 values I'm going to get. Coefficients will be beta 1, beta 2, beta 3, and the intercept will be beta naught only. But only these value, earlier in the multiple linear regression, how you got these 4 values means, in the multiple linear regression, how you got these 4 values means, it has to form this such a way that the sum of the squares of error should be minimum. Now, how you are going to calculate the same 4 values means, same to same 4 values. Again, you are going to calculate the same 4 values. But instead of substituting that equation, you are substituting this equation. Which equation? The new equation is, instead of going with the sigma of y minus y hat whole square only, you are adding alpha into slope square. This one also you are going to add. That's it. That is the only additional you are going to add. There, how you calculated d by dx. Here also you are going to apply the same d by dx logic. In that, whatever the max was happened in the backend and how it is calculated, the beta 1, beta 2, beta 3, same to same, it is going to apply here also. There will be no difference. The only difference in the both of the cases is additional penalty term. This is the only difference. Is that clear? Now, by adding this penalty term, what happens means it is reducing the overfitting problem. Earlier, we have faced some kind of overfitting problem that will be reduced in the ridge regression. Now, ridge regression or lasso regression or elastic net regression, these 3 of them, when we have to apply means if you are having any kind of overfitting problem. Sir, for me, for example, there is no overfitting problem, sir. Nothing is there. Then this is not having that much of impact. When in case of overfitting problem, for overfitting problem, this is going to have very good impact and it is going to be one of the solution. One of the solution. Remember that one. One of the solution. This is not the ultimate solution. It is one of the solution. For example, there is no overfitting only. No overfitting only is there. Still, we are going to apply the lasso ridge also. Why? Still, why we are going to apply? Maybe you may get better answer. Though there is no overfitting, for example, let us take like this. Here, no overfitting means in your linear regression, you have got the test train accuracy. train accuracy of 74%, test of 76%, which is not having overfitting problem in your linear regression. Okay. For example, though it is not having overfitting also, still you applied. Still you applied. There is no overfitting, but still you applied. Now you may get train is equal to, instead of 74 will be 74 as it is. Test may increase to 77. Who knows? It might increase, it might decrease also. We can't say exactly anything what happens unless we apply. Unless in the entire machine learning, the only problem is nothing we can identify what would be the expected output. Right? So in terms of by modeling, it is going to increase the accuracy or decrease the accuracy without applying, we can't predict. By seeing the data, see here the data set will be like this. This is the data set. For example, I'm going to load one of the data set now. Let us assume this is the data set. This is the data set is called as insurance data set, where we have to predict the expected expenses. What would be the expenses, right? Now, this is the output variable which we have to predict. This is the output variable which we have to predict expenses based on the input variable. Now, if you observe here, the total records, how many records are there means 1338 records. If I open all my 1338 records also, by seeing the data set, can we decide anything miss? Nothing we can decide. So if for example, if you want to see entire data set, okay, if you want to see complete entire data set, how it is going to work, right? Entire data set, if you want to see, I'm printing here DF. So you can see here only first 5 records and last 5 records. But still I want to see the entire records. So how I can see the entire records means here there is a option called as PD, pandas dot display maximum columns, display max columns, display maximum columns. In bracket, you can take none. Just give me a minute. PD dot into max column. You can take max columns is equal to 10,000. Just set options. Okay. Okay, max rows. We can go with the max rows also. PD dot set option, display max rows with respect to 5,000. For example, I'm asking like this. So now you can see the entire rows up to maximum of 5,000 rows you can see. Now by seeing this one, so I have told you that what is the shape. Here the shape is 1338,7. Now if you see this 1338,7, that is total 1338 records are there here. 1338 records are there. If you see these records, by seeing the records, can we say that linear regression will give the best answer, or elastic net will be giving the best answer, or lasso? We can't decide by seeing the data. By seeing the data, nothing we can decide. Sir, now just we are trying to fit on the scatter plot. Now in the scatter plot, we can take only two columns at a time. only 2 columns at a time, right? Scatter plot is a bivariate analysis where we can apply only on the 2 columns at a time. For example, I'm taking the age versus expenses. Okay. And similarly, gender versus expenses, BMI versus expenses. Now, if I consider like this also, here I can't predict based on the entire scatter plot or using the EDA also, we can't say that this particular machine learning algorithm will give always the best answer. We can't say like that. That is not possible. In entire machine learning, that is not possible. So then what we have to do is we have to try all the algorithms. We have to try all the algorithms which are suitable for the given data set. If the given data set output variable is available, means supervised machine learning, and that too the output variable is continuous. If the output variable is continuous, means it is a regression. For regression, whatever the regression algorithms are there, all the regression algorithms we have to apply. Simple. By seeing the data set, we can't conclude anything. Whether if you see the complete data set also, you can't conclude anything. By seeing the first 5 records also, you can't conclude anything. If you write here head function only, first 5 records also, you can't conclude anything. Right? So now displaying the maximum rows, if entire data, if you ask to display also, there'll be no use for us. Okay, there is nothing special in the displaying of all the rows. Right? Now, here, if you observe this one, this particular data is consisting of 1338,7, out of which, if you see here, I'm having the column names called as age, gender, BMI, number of children, smoker, whether the person is a smoker or not, and region, and finally the expenses. Okay, which is the output variable. So I want to predict the expenses. This one, I have to predict the expenses based on this. Now here, what I'm going to do, I'm going to separate the data. I want to separate the whichever the columns. In these columns, I'm having first age. Tell me what is age? Age is a continuous variable or discrete variable? It is a continuous variable. Next, gender. Gender is a discrete categorical, whether you will have either female or male or something, right? Now, second, we are having in terms of next one is BMI. BMI is again continuous variable. Next, children. Children is in terms of how many number of people are there. How many children this person is having, how many children? Either 0 or 1 or 2 or 3 or 4. Count. It is a count variable. So again, it is a discrete count variable. It is counting. For children, 1.2 is not possible. We can't take as a continuous variable. Count. It is just counting. Similarly, next, smoker. Whether the person is a smoker or not. Yes or no. Again, it is a discrete categorical. Region. Again, region is a discrete categorical. Now I'm having a data like this. And where the final output expenses is a output variable which is continuous. Right? Now, here this is a continuous variable, and these are all the discrete variable, continuous and discrete, which is input variables. Now, for continuous variable, I have to apply continuous variable analysis. That is scatter plot or box plot or histograms. These things I have to apply for this. Remaining for discrete categorical, I have to apply the bar plot and value counts. I have to see how many different categories are there. For example, within the gender, what are the different categories? For example, I'm having small letters female and small letters MALE. And sometimes you may have like this, caps lock MALE. Caps lock F will be there. This is third category. Third category, whenever you are having like this, then what we have to do? We have to apply the replace. We have to replace this data to small f, so that we'll have the only 2 categories. Okay, though these both of them belongs to the same only, right? Sometimes we may have some females will be like this, caps lock, everything. It will show as a 4th category. It is not a 4th category. It is also a one of the category of that one only. So this one also should be replaced with the small letters. That is a wrong data. If you keep this one as it is, sir, it is almost same only now. If you keep as it is, then automatically when you apply the one hot encoding, automatically you get a new columns, multiple new columns. It is considering this one as a different category. This is not a different category. This one, and this one, these 3 of them are same category. Whether we are having like this or not, how we can know means first we have to see that one. To see that one, we have to do the exploratory data analysis. For doing the exploratory data analysis, first we have to separate the data. Which data is with respect to continuous, which is discrete, that we have to separate. Now here, continuous variable. What are the list of continuous? I'm going to take a continuous is equal to list of, first one is age, second one is BMI. These are the two, and along with the output variable, that is expenses. These three of them I'm going to take into a list of continuous variables. Next, I'm going to take the next one called as discrete categorical or discrete count. Both are discrete only. Categorical or discrete count, both are discrete only, right? So the remaining columns, whatever I'm having, the gender column and the children column, smoker column, and region column, all these things I'm going to consider in the discrete variable. So that now I'm going to apply the pair plot on this continuous variable only. Okay, multivariate analysis. Similarly, correlation coefficient, I will apply only on the continuous variable, and I will check is there any correlation between the two independent variables is high. At the same time, the relation between independent variable versus output variable. Is there any collinearity problem is there or not? All these things I'm going to see one by one. So for that, what I'm going to do, I'm going to separate the data of continuous variable and discrete variable. Now, if you remember this one, in the last class, we have not done this one. So in the last class, we have not done anything, right? Directly you have considered a TV, radio, newspaper, and you have continued. Why in the today's class you are going to do this one, miss? In the last class, three of them are continuous only. No discrete variable is there. No need of encoding or no need of anything. There is no discrete variable in the last class. In the last project, whatever we have worked on the TV, radio, newspaper, and sales data set. In that data set, there is no discrete variable. Since there is no discrete variable, I have not separated the data because everything is continuous only. No need to separate also. TV is a continuous variable, radio is a continuous variable, newspaper is a continuous variable, and output is also a continuous variable. But today's data set having the continuous and discrete. So I'm separating. That is the reason. Second, now, sir, here you are having only 7 variables. So you are doing manually. But I assume that I'm having 35 variables or 40 variables or 500 variables, 500 columns are there, something like this. Then what I have to do? In that case also, should I write manually like this? Then how it is possible, miss? That is not possible. So in that case, what we are going to do, I'm going to take the for loop. I'm going to apply the for loop. Now for loop, within the for loop, I'm going to take the dictionary of the DF of D types. D types means what is D types? It is going to give the data types. What are the different data types in pandas? Either int, float, or object. These are the 3 things. So if whatever the D type, if the D type is equal to object, it is automatically considered under the categorical variables. Thus comes under categorical. Whichever is in the float, automatically it will comes under continuous. Whichever is in the int, this one only problem. Whether it is a discrete count variable or continuous variable, we don't know. That is only the problem. So that one we have to check. So I'm going to append into 3 empty lists like this. One is categorical, one is continuous, and one is check. Now what happens here? First it will going to take the int 64. Oh, int is there. Since it is a int, it is going to get into the check. Check means you are going to check. Okay. Next, object. Object means blindly it is a categorical. Float. Float means continuous. Int. Int means again check. Object. Object means categorical. Object. Categorical. This is continuous. Now you are going to check this one. Children. In the children, it is also in the numerical format. Children also in the numerical format. Age also in the numerical format. Both of them are in the numerical format, and both of them are not having the decimal values. But children comes under discrete count variable, but whereas age comes under continuous variable. It is not considered as a discrete count. Okay. Now, for example, salaries are there. Salary of a person. Salary of a person is 3.25 lakhs. Sorry, instead of 3.25 lakhs, I'm writing 3,25,000. Both are same only, right? 3,25,000, 4,50,000, 4,61,000, 4,62,000, 9 lakhs for 12,000, something I'm having. Now tell me whether it is a count variable or a continuous variable. It is a continuous variable. It is not a count variable. Why? Because if you consider this one as a categorical categories, it is category. Yeah. This is not a category, right? Discrete. Discrete means whether it is a count or whether it is a categorical, it is category. Discrete means only it is category. Discrete means separate. Two different categories. Though that is different category, this is a different category. Discrete. They are not connected to each other. No connection. So here, if you go with the children, in the children case, I'm having the 0, 1, 2, 3, something like this. Each one is a category. Zero children is one category. Having one children is one category. Having two children is one category. Having three children is one category. They are discrete. They are not having any dependency between them. Right? Is that clear, guys? So like this, I'm separating the data. And after separating the data, now I'm checking whether which one comes under which category. Now from that, I'm going to separate the data. And finally, I'm going to take continuous variable and discrete variable. Okay. Now here, whichever is a categorical variable, for each categorical variable, I'm going to apply the value counts. So now in the gender column, we are having in terms of two categories are there. Two unique categories are there. One is male and one is female. And their counts. Similarly, in the smoker, I'm having two categories, no and yes. In the region, I'm having southeast, southwest, northwest, northeast. So each, wherever the categorical variable is there, for each categorical variable, I have applied this one. Now the question is, okay, sir, for categorical variable, you have applied nice. But the problem is not this one, right? The problem is here. The futures to be checked is age, comma, children. We have checked. Now what I'm going to do here, in this case, I'm going to write the word called as continuous. First, I have to write continuous. Is equal to list of whatever the continuous futures are there. As it is, I'm copying here. And additional to that, whichever the futures you have checked, that is age and children. Within this, which one is continuous? Age is continuous. Copy this one. And that one also you select here. Okay, whichever you felt continuous, that one you take here. And next one is discrete. Now you go with the discrete. Now for discrete variables, whatever the discrete variables are there, that is categorical. All the categorical comes under discrete. All the categorical comes under discrete. And along with that, whatever the futures you have checked as the discrete variable, copy this one also into a discrete variable. Like this, you have to separate the category continuous and discrete in the real life. Directly categorical variable and continuous will be separated easily. Wherever the int is there, this one only we have to check. Right? Once we have checked now, I'm having the discrete variables with me and continuous variables with me separately. Now we are going to process the data. Simple. So we are going to apply the describe function. Now once the describe is completed, now in the describe, if you observe here, age column okay, BMI column okay, children it is taking. Children is a discrete count variable, but still it is applying. Basically descriptive statistics, whatever the mean, standard deviation, minimum, percentage, all these are applicable only on the continuous data. For discrete variable, can you calculate the standard deviation? For discrete variable, can you calculate the mean value? No, that is not possible. But still, why it is considering? Because for the children, since it is in the numerical format, whichever the data is in the numerical format, it is considering. So we should not consider in that way, miss. Then what we have to write here? Include. Include is equal to, you have to write the word called as include. And you can write the continuous. Include is equal to continuous. So now if you write include is equal to continuous, include data type BMI not understood. Data type BMI not understood. Yes. So here it is going to apply for the discrete variable also. If you don't write this one, I have to take only the discrete function only for continuous variable. It is taking for the discrete count also. This is discrete count. This is the discrete count variable. Now, if you observe here, it is saying that how many children, what is the average children means it is saying 1.09 is the average children. 1.09 average children will be there. But discrete variable, you should not apply this one. So only for continuous data only, we have to take this one. We can't apply as per our choice, right? Only we have to take with respect to for continuous variables only, not for the with respect to for discrete variables. Similarly, correlation coefficient also same. Now the correlation coefficient, whatever the DF of continuous, only continuous variable. If you take only the continuous variable, you can have like this. Now in the continuous variable, what I'm going to do is I'm going to take this expenses in the output, the last one. I'm keeping in the order of this one in the last portion. Okay, now you can see here BMI versus age, that is 0.10, means between two independent variables, the correlation is very low. Since the correlation is very low, there is no collinearity problem. Now BMI versus output variable, that is 0.198 along with the age versus output variable 0.29. This is the with respect to output variable. Our problem is between two independent variables, the correlation should be very low. Yes, it is very low. So there is no collinearity